Welcome to another video for Ivy Tech Community College. And in this video, we're going to be working on the assembly that you see here. And what we're going to do for this is we're going to create a complete packet of working drawings. So we're going to try and get through this as quick as we can, but we're going to model each piece, model the assembly, and then put together our drawing pages. So this is going to be a project that might take you a little bit longer, but it's going to give us a chance to take everything that we've talked about and put it all together. So you can see all the dimensions come from figure 5-13. So we're going to be modeling really about 6 different pieces. And you can see how they kind of come together here. So I'm going to start by just kind of working my way down the page, and I'm going to be making these all as metric files. So notice everything is measured in millimeters. So I'm going to start by making this piece, then the cross length, the bushing, the base holder, the link down here, and then finally I'll make the 5x11 peg, which shouldn't take very long. So I'm going to start by modeling all these pieces, then I'll put them together into an assembly file, take that assembly file and turn it into an exploded view, and then finally I'll take all that information that I've made and put it onto the Ivy Tech template and make a packet of working drawings. So we're going to try and put everything together here. Now when we make our packet of working drawings, here's the format that I want you to follow. I want page 1 to be the exploded/assembly page, where you put both of the exploded and assembled views with a parts list and the note bubbles, and then pages 2 through 6 will be your part drawings. So page 2 is the holder arm, 3 is the cross link, 4 is the bushing, and so on and so forth. We're not going to make a separate drawing page for this peg. It's so simple that we can give the dimensions to it in our parts list on our assembly page. So when we describe this part in the parts list, we'll just say 5x11 peg, and from there they'll be able to figure out anything they need to know about the part. So we're going to assume that this is a standardized part, and we're not going to make a separate drawing page for it because it's so simple. All the other pieces will get their own drawing pages though. Okay, so I'm going to go ahead and start making these pieces. I'm going to start with this one. I would recommend you take this page. It's in Blackboard. Download it or print it out. That way you can have it. I'll jump back to it occasionally to reference it, but I do have it printed out in front of me also, and it makes it a little easier instead of trying to jump back and forth and look at all the dimensions all the time. So I would recommend you take this page and print it out because it has everything you need on one page, and it'll make your life a little easier as you model. I'm also going to start by jumping into a standard millimeter eye part using my metric template. And we're going to go a little bit quicker on this, so I'm not going to explain every single click because hopefully some of this is familiar to you at this point, but I am going to model the entire thing as I record it. So I'm going to start just 2D sketching like I usually do, and I always like to project in my X and Y axes while I'm sketching. And for this one, I'm just going to start by putting a circle here, and then another one up here somewhere. And I'm going to put one more circle on the outside of all those. Now I'm going to use my equals constraint to make the small circles all equal to each other, and pick it again and make the big circles all equal to each other. Now I'll draw tangent lines in between them. So I'm going to start by just drawing a line up here somewhere. Draw a line out here, and then one down here. And instead of trying to connect them at the beginning, what I can do then is I can just take my tangent tool and say these are supposed to be tangent, that's tangent, this is tangent, this is tangent, tangent, and tangent, which is assumed. Okay. Now I'll just grab my extend tool and make sure everything is touching. So make sure you have a closed profile sketch here. So I'll extend those, and then this one I need to trim off. So I'll grab my trim tool and trim that one. Okay, so I've defined the basic shape of this part. I also want it to be symmetric, so when this side moves over here, I'd like for this side to move as well. So what I'm going to do is use my symmetry constraint and say that this circle and this circle need to be symmetric around this center line. Now what that does is notice that these move together, and it's going to make it a lot easier when I dimension this. So I'm going to go ahead and put some dimensions on, but before I do that, I'm going to trim off these other pieces here on these circles that aren't needed. And now we're ready for dimensions. So grabbing my dimension tool, these should be a diameter of 5, so I'll go ahead and dimension those. The fillets on the outside should be a radius of 5, or twice as big. My distance here to here should be 20. And then my vertical distance from here to here should be 10. Okay, so if you use your geometric constraints and your dimensions correctly on this, you really don't need a whole bunch of dimensions. You really shouldn't have any more than 4 there. So notice how I've completely defined this part. So I'll hit finish, extrude it out, choose my profile. I'm going to go with a symmetric extrusion so that it goes equally in both directions, and my total distance is going to be 5. So we'll hit OK, and that part's done. We'll go ahead and save it. And I'm just going to make a folder on my desktop where I can keep all these pieces, and I'll just call it Lab Q. And you may want to put your last name in there. So maybe let's do that. Let's say Hamilton Lab Q. And this part we're just going to call the holder arm. So we'll save that. And that piece is finished. So we'll go ahead and close it and jump right into the next one. So we're doing another metric part, another 2D sketch, XY plane, project your geometry. So you'll see how you get faster at this because it becomes so repetitive after a while that you just kind of get to where you're used to doing it. Now on this piece, there's a great tool that we can use in Inventor that's called the slot tool that's going to be very useful for drawing this. So see the basic shape of this. If I drop down the rectangle tool, the center to center slot tool is perfect for this. So I can basically pick my 2 points and draw a slot and just draw circles where they're concentric with the 2 arcs on the ends. And now as this moves, that side will follow this side, hopefully. So to make that happen, I'm going to make this symmetric also, because you can see right now as this side moves, the other side is not moving proportionally. So I'm going to say that this arc and this arc need to be symmetric around this center line. Now when I move one, the other moves proportionally. And same thing in this direction. So at this point I just need to put some dimensions on here. So I'm going to say the small circles have a diameter of 5. The arcs have a radius of 5. And then our center to center distance should be 40. Okay, and then this one, see, I forgot to make that equals. So instead of dimensioning this one, I'm going to say that this one needs to be equal to this one. Okay, so this whole part I can do using the slot tool and the circle tool with 3 dimensions. So try to use as many geometric constraints as you need and as few dimensions as you have to use. Okay, so try to minimize dimensions. So I'm going to hit finish. We'll go to extrude, choose my profile, go symmetric, and on this one, this is also 5 millimeters thick. So we'll hit OK. And we'll just go ahead and save this. And this piece is called the cross link. We'll save that one and close it out, and we're ready for the next one. So on this piece, we're going to make the bushing, which this is a very easy piece, just 2 circles and extrude it out. So we've got a diameter of 5 and 20 with a depth of 15. So I'll go with a sketch, XY. I'm not going to project the geometry this time since it's round. All I need is the origin point to draw my 2 circles and fully constrain them. So this one's going to be 20. This one's going to be 5. Hit finish. I'm going to extrude that out symmetrically at a distance of 15. That one's done. We'll save it. And this one is called the bushing. And we're ready for the 4th piece. So you can see how once you get the fundamentals of modeling down, these pieces usually are fairly quick. Now this piece is probably going to be the most difficult, but really it's not too bad. We have this kind of T-shaped bracket, and it's got 3 holes in it. I'm going to add the fillets on at the end actually as a model feature to kind of simplify the sketch. So I'm going to just sketch out this basic shape and then put the holes in it. So going to a 2D sketch on the XY plane, I'll project in my geometry, X and Y. And on this one I'm going to start by just sketching out the basic shape of the part. And notice I don't dimension it till the end. Okay, so there's the basic shape. I also know about this part that I want these to be collinear. So if they're not, make sure you grab your collinear tool and make these 2 collinear so that they basically lie on the same point in space. I'd also like for this part to be symmetric around the vertical axis. So you can see it's not right now. So I'm going to grab my symmetry tool and say this line and this line need to be symmetric around this one. Now they behave together like they should. And I'm going to do the same thing with this one and this one. They should be symmetric around this line. Doing this allows me to minimize the number of dimensions that I need to define this part. So now I can grab my dimension tool, and I know my total height from here to here is going to be 35. The height of this section is 5. The width of this section is 40. And I'm just going to drag this out a little bit farther. And then this distance all the way across, if I've looked at this correctly, should be 80. Okay, so there's our basic sizes. I'm not going to put anything else in there right now except for the circle. To kind of save me a step, I'm going to go ahead and put this circle in here, just kind of in there in the middle, and I know the diameter of that circle should be 20. And as far as its location, I want it to sit on this line, but its vertical location should be 20 up off the bottom. So from here to here should be 20. And now I can go ahead and extrude this out. So I'll hit finish, go to extrude, choose my profile. I'm going to go symmetrically again, and my depth on this is going to be 20. We'll hit OK. And now I'm going to go ahead and add in the 2 holes. So I'm going to just pick this face for my sketch. And I'm going to project in this surface and this surface, and just sketch my circles in there at the same time. I'm going to say they need to be equal in size to each other. And I'll dimension the first one up here, and its size should be 10. And now I just need to center them up. So I'm going to say that the distance from here to here should be 10. The distance from here to here should be 10. So that one's fully defined. And I can do the same thing down here. So 10 that way, and 10 that way. Okay, so they turn purple, they're fully defined. I'll hit finish. I'll go to extrude and choose those 2 profiles. So I'm going to choose this circle and this one. So let's rotate around here a little bit so we can see that. And I need to cut those out, so I'm going to choose the cut option instead. And I'm going to say 2, and I want to cut down to this face. Or you could also say through all. That would work also if you want to say all. I like to use the 2 option. So I'll hit OK there. And now the only other thing we need to add on this part is the fillets. So there are fillets on this part on these edges, and they should be a radius of 3. So I'm going to go to my fillet tool, just put in a size of 3, and then just click the edges that I want to put the fillets on. And you can get them all at the same time. That looks good, so I'll hit apply and cancel, and we have another part finished. So we'll go ahead and save this now. And this part is called the base holder. It's called the holder base, actually. Looks like is the correct name. So the holder base, we'll hit save. And now we're going to make another link, which is similar to the cross link. So I'm going to show you another trick here to kind of save some time. And here's kind of where correctly defining your parts will save you a lot of time. So notice these 2 parts are identical except for the length. This one is a length of 40, this one's a length of 50, but everything else about the parts is exactly the same. So instead of completely remodeling this in Inventor, I'm going to open up the other one. So if I go to my folder of parts, I'm going to open up this cross link. And before I do anything to it, I'm going to do a save as. So I'm going to save this as a different file name, and the file name I'm going to save it as is going to be this one. So I'm just going to call it link. Okay, so I'm going to create a copy of this file and call it link and save it. Okay, and you'll see it has a new name up here now. So I'm now working in the new file that I called link, which is a copy of the other one. And to change this, I'm just going to go into my sketch and right click and go to edit sketch, change this dimension to 50. And if you use geometric constraints and completely define your parts, that should be the only thing you have to change. Now I hit finish, the part updates itself, I hit save, and that part's done. So there's an example of where using your constraints will actually save you a lot of time. So that piece is finished. If you model your parts in a sloppy way or you don't constrain them intelligently, then this is going to end up taking you just as much time as that one. But if you do it the smart, correct way, you're going to be done already. So the last piece I need to make is the peg. It's just a diameter of 5, 11 millimeters long. So that should be pretty easy. So let's go standard millimeter part, make a sketch. I'm just going to make a circle that has a diameter of 5 and extrude it out symmetrically in both directions, a distance of 11. And we'll save that and we'll just call it peg. So that piece is now finished. And one other thing that I'm going to do that might be kind of fun here, you don't have to do this, but I'm going to put some material types on these parts. So I'm going to open up this bushing, for instance, and I'm going to choose up here at the top and just set its material type to something that might actually get used for a bushing. So let's just say for our bushing, maybe we're going to use nylon. Maybe that would be a good material. So let's say the bushing is nylon. I'll save that and close it. So you can see I put the material type up here. And I'm going to open up some of these other pieces. So let's open up the links. And I'm going to choose the first link, and let's just say that it is, maybe it's stainless steel. So we'll just say it's stainless steel. And you can see a slight change in it when you do that. So I'll close that. I'm going to say this one is also stainless steel. Save that and close it. And if we open up some more parts, we've got the holder arm and the base and the peg. So let's open those three up. And you could do this when you model them also. So let's say the peg is going to be, let's make it stainless steel also. This holder base, let's do something a little different on it. Let's say that this is going to be just for fun, let's say it's aluminum, maybe 6061 aluminum. Save that, close it, and finally this holder arm, let's say that that is maybe made out of just mild steel. Okay, so we'll save that. So now we've got some different material types on these parts, make them look a little bit more realistic. Okay, so I'm going to go ahead now and assemble these parts. So I'm going to go to New Metric Assembly. So I'm going to find a standard millimeter assembly, hit Create, and looking at this part, the best part to start with as my base feature would probably be this holder base. It's the biggest, kind of most important part. So I'm going to use it as my first piece. So I'm going to go to Place and find my folder of parts. And I'm going to start by placing the holder base in there. So I'm just going to drop it in there and say OK. And I want to put this right at the origin of my assembly file. So you can see right here is the X, Y, and Z planes for my assembly file. So where those three come together is the 0, 0, 0 point of my assembly. My model is going to have a different 0, 0, 0 point. So what I want to do really is constrain that to the 0, 0, 0 point of my assembly file. Or you could also, if you want, you could just fix it somewhere in space. So I can right click this and just say grounded, and that means that that piece is always going to sit right there and it's not going to move. Okay, so sometimes I just pick a piece and ground it and kind of use that. So here's my front view. Okay, we're going to go ahead and bring in the other pieces. So I like to set my first piece and then bring in all the other ones at the same time if there's not too many of them. So we're going to bring in the bushing. We just need one. We'll go right back. We're going to bring in the cross link. We just need one of those. We're going to bring in the holder arm, one of those. We need the other link, two of those, which is the longer size. And then the peg, which we need 4 of, or actually 5. I'm not sure I follow their logic there, but they say down here 4 are required, but I'm counting 5. and to me this one's going to need to be longer. So where they say 5 by 11, I don't think that's going to work. I think we're going to need to make another one. So looking at this, if I make this thing only 11 millimeters long, it's not going to go too far into this part. So we may make an additional peg to make this thing fit together better. So I think this might be a mistake here on the length. They want an offset of 1 millimeter between everything. So if I have a part that's 5 millimeters thick, plus another millimeter, that would be 6, plus 15 more, we really want a peg that's 21. So I'm going to put in 4 short pegs, and let's just make another one that's 21. That way that peg will go all the way through to the back of this bushing. So I think that's a mistake. This should be 21 by my calculations. Let's go ahead and put 4 of the small pegs, and then let's make one new one real quick. So I'm going to open this peg, and let's just go File, Save As, and let's just call it long peg. Hit Save, and let's just edit the extrusion depth from 11 up to 21. Hit OK, and then save it. Close it. Go to Place, pick the long peg, and just throw that in. So hopefully that'll make our assembly turn out a little bit better. Okay, so the first thing that I'm going to do is put the bushing inside of the holder. So I'm going to go to Constrain, and this is going to be an insert constraint. So I'm going to choose this option and just pick the front edge of that and the front edge of that, hit Apply, and those two are put together. So that's a pretty easy one. I'm going to go ahead and put this peg in also. So I'm going to go to Constrain, go to Insert again. I'm going to pick the back edge here, and then rotate around and pick the back edge of this bushing. And put those together. You can see that gives us some slack here on the front we can use. Now I'm going to put the holder on there, and my size of my peg should define it, because I said I wanted a 1 millimeter clearance between those. So I'm going to say I'm going to pick this face and this face for my insert, hit Apply, and that should give me a 1 millimeter clearance in between there, so it looks like we did our calculation right. That's looking really nice. Okay, let's go ahead and put some more pieces on here. So let's grab the back of this piece and constrain it to the back of this hole. So this is pretty repetitive. You can do this entire thing really with insert constraints from what I'm seeing. So I'm going to pick this edge, constrain it to this edge, and let's grab the front of these long links now, or really the back of them would be better. Let's take, oh no, I'm thinking wrong. Let's take the front. So let's take the front here and constrain it to the front here. And I'm just going to hit cancel for a second and kind of drag this down where I want it. So since this thing rotates, you've got some freedom here as to how it's going to behave. So you can kind of drag it around wherever you need it. I'm going to go right back into constrain, pick my insert again, and say I want this face constrained to this face. And now we're going to put more pegs in there. So let's take this peg and constrain it to this hole, and this peg constrained to this hole. And now I'm going to take this surface, whoops, let's take the back of that. So we're going to take the back of this piece and constrain it here. Whoops, didn't get that one right. Let's try it again. We're going to take this surface and constrain it to this surface. That looks better. And then you probably will want to drag this thing into shape a little bit. So I'm going to hit escape a couple times and just kind of drag this around to where it's a little bit closer. There, that's more like what we want. So just kind of trial and error, drag it around to where you get it where you want it. I'm going to go to Constrain, Insert, and put these two together. Okay, so once you get all your inserts put together, this is where you can kind of mess around and play with the thing and have some fun with it. So I like to leave these pieces where they move. I don't think that's hurting anything because that's how it would actually function in real life. You might want to try and kind of center some stuff up here. So if you wanted it to look perfect where it's perfectly vertical for your presentation, you could put a flush constraint between this face and this face if you wanted, and kind of line things up specifically that way. Or you could do, flush constraints between these two, but I don't see anything wrong with just kind of leaving it where it can move. I think it's kind of fun to mess with. So let's leave the assembly like that. and we'll just go ahead and save it. And I'm just going to call this Hamilton Lab Q. So there's my assembly file. I'll hit save. We'll close that out. And now we're ready to make our presentation file. So I'm going to go to a metric IPN file down here at the bottom, standard millimeter IPN. I'm going to go ahead and create a view and choose my assembly file. And I'm going to manually explode this, so I'll just hit OK. And I'm going to go to Tweak Components. Now, this one's going to be a little different the way that we explode it. Mostly it's going to be pieces coming out this way, is how I'm going to do it. So I'm going to go to Tweak Components. Okay, and I'm going to say the parts that I want to select are going to be basically everything except the main block. And I want to locate those. So I'm just going to bring them out this way. And I just like to drag the pieces out to where they kind of just barely overlap, or sometimes don't touch at all. I'm going to leave a little bit of overlap on these parts, because if I try to pull them all the way apart, this exploded view is going to get to be humongous. So we'll hit OK there. I'm going to rotate around the back now and see if I can pull this pin out of this piece and kind of show it in the back. So I'm going to go back into Tweak Components. The part I'm going to choose is this one, and I'll go to Locate. I'm going to pull that piece back this way. Whoops, picked too much there. Let's cancel out of that and try that again. There we go. We'll just pull that back and kind of rotate around to where we can see it better. That's going to be pretty good right there probably. So I'll just OK that. Go back to my isometric view here. And the next thing I'm going to do is kind of pull all these pieces off the front. So I'll go to Tweak Components, go to my part, and I'm going to pull everything here off of this piece. And actually we could leave these behind, so let's leave that there. So I'm going to control click these to unselect those. So I'm going to leave this part and this part now. And take all the pins. So I'm going to go to Locate, pick the front of this piece, and just kind of pull those out. And right there would be perfect. So I'll stop there, hit OK. And now I'm just going to grab these two links. So I'll go to Tweak Components. The part I'm going to pick is going to be this piece and this piece. And locate those. And just pull those out a little bit farther. Kind of like that. This is kind of a tricky piece to explode, but I think that kind of gets the general point across. Probably could put a little more space in between these. So let's adjust that a little bit. Let's go to Tweak Components and pick these three parts. So I'm going to pick those three parts and locate them back this way just a little bit. Put some more space in between there. We'll hit OK. And this is just kind of an artistic thing. There's no necessarily right or wrong way to do this, but there are good ways and bad ways. So you want to keep things organized and explode them in a direction that makes sense. So try to think about how they would go together in real life. And if you want, you can kind of animate this just for fun and see how they come together. So that's kind of a neat one, I think, to see how it comes together. So I'll go ahead and save this now. And I'll just call that Hamilton Lab Q again. Since it's an IPN file, I can just give it the same name. I'll hit yes to all and OK to save everything. And there we have everything modeled. So now we just have to make the drawing pages. So without really too much time, we've got everything modeled and we're onto the drawing page parts. You can really put these projects together pretty quick when you get practiced up at this. So I'm going to go to New, IV Tech. We're going to do a metric template. So I choose my millimeter template. This is going to be my drawing page. So I'm going to say this is going to be, we'll just call this link assembly. Put in my name, today's date, this will be millimeters. The scale I don't know yet, so we'll go back and fill that in. And we'll hit OK. Okay, now I'm going to go ahead and just make a base view of my assembly drawing here. So I'll start by picking my assembly file. And I'm going to do a custom view on that. So let's go here and just kind of rotate this around. That looks pretty good. The scale's a little small. I can get away with a 1:1 scale on this. That looks pretty nice. So I'm going to go 1:1 scale on this view. And I'm just going to put that over here probably and hit OK. Okay, and there's my assembly view. I'm just going to double click it and set that to be shaded. And hit OK. That looks a little better and it shows the material types. And now we'll just make another drawing view of our presentation file. So I'll pick my presentation file. And kind of drag that around. Let's see if I can squeeze that in at a 1:1 scale. That's going to be perfect. So we'll show that at a 1:1 scale. Shaded also. We'll hit OK. And I'm just going to drag this over. I don't like having these lines on here necessarily. Those are called trails. I'm going to turn those off just to kind of clean my view up a little bit. That's going to fit on there really nicely. So we'll go ahead and just pull this down, kind of get it to where it fits. Before I forget, I'm going to come up here and fill out my scale and just say that this is a 1:1 scale. Hit OK. And now we can make our parts list. So I'm going to go to Annotate, Parts List, make a parts list for this view, and just hit OK. And I'm just going to put that tight up here in the corner. And I don't need this description page really. So I'm just going to double click this and go to where I have the column chooser. I'm just going to turn off the description column. I don't even need it. So we'll just hit OK. And down here for the pegs, I'm going to say in parentheses 5:11. And then down here for the long peg, I'm just going to say parentheses 5:21. And that's what lets us not make a drawing page for those two. So by doing that, I can eliminate making a drawing page for both of those views. So I'll pull this down a little bit more so everything fits and adjust this one a little bit. There we go. Now we can just put our notes on there. So let's put our note balloons. And you don't have to worry about the numbers matching up. Remember, Inventor will pick that part up for you. So just try to keep them where they look nice. And just do each type of part once. So each unique part just gets one number. And you can check when you get done that you should be able to count 1 through 7 to know that you have them all. Okay, so there's my assembly page, completely done without too much work. So I'm just going to go ahead and save this drawing file first, in case I get a crash or something. Okay, so there is our first page. So remember, we're making 6 pages, so the first one's done. Now we need to make a bunch of different part drawings. So what I'm going to do is go through and set up all the pages first, and then go back and do my dimensioning. So I like to kind of do things in batches if I can. So I'm going to go to New Sheet. I'm going to call this one Link Assembly, and this is going to be the holder arm. So you're going to get pretty good at filling out this title block. It unfortunately can become kind of a hassle, but it's still a lot faster than trying to do it in AutoCAD. Okay, so I'll go ahead and place my views now. So I'm going to go to a base view of the holder arm, and that would make a great front view. I'm just going to scale it up a little bit. So let's go a 2:1 scale on this. And we want to show hidden lines, so we've got that, so we'll hit OK. and I'm going to project my views off of that. So I'm going to project a view, oops, let's go projected and project a view over and up and then an isometric. Okay, and I'm going to set the isometric to be shaded, try and make it look a little nicer, and tighten these views up just a little bit maybe. Okay, so that page is set up now. We can fill out the scale. So I went ahead and used a 2:1 scale on this one. So let's go to the field text, and we're going to say this is a 2:1 scale drawing. Okay, we'll go ahead and make our next one. So we'll come back and dimension all these in a minute. So I'll come back and do the center lines and the dimensions after I get these pages set up. So I like to go through and set up all the pages. So I'm going to say link assembly, and the next page is going to be the cross link. And the rest of this should all be the same. And go to my base view and pick the cross link. And that's probably a great scale right there. I could try a 3:1, but that's going to be too big probably. So let's just stick with 2:1. That's a pretty good scale, and it shows enough detail for a part this simple. Okay, and then I'll go to projected, pull off my other two views and my isometric, and set my isometric to be shaded. Okay, and I'll go ahead and hit save just to be safe here. And we're ready for page 4. So page 4 is going to be the bushing, if I remember right. Yeah, so page 4 is going to be our bushing. So we're going to say on this one, link assembly bushing. And we'll go to our base view. And you can see I like to do things that are repetitive. It keeps me from having to think as much. So if I set all these sheets up at once, then it kind of minimizes the frustration of setting them up. So I'm just going to do one view. You can see if I pull this view off, it would be identical to this one. So there's really no reason to do 3 views on this one. I'm still going to do an isometric though. So this is a terribly simple part, so we can get away with 2 views on it. And we'll set this one to be shaded. And we'll say that our scale here is going to be 2:1 again. Okay, and I believe I forgot to fill out my scale on this page, which I did, so always double check your title blocks, make sure you got everything filled out. So on this one, it should be a 2:1 scale. So that's sheet 4, so we need to make the base holder and then the link. Okay, so I'll choose my view. This one I'd like to get a little bit bigger if I can. Unfortunately, 2:1 is going to be way too big, so I think we're just going to have to go with 1:1 on this one. It's not the best size, but it should get the job done. So I'll create those views. And this one is going to have more dimensions, so if I leave myself some room for dimensioning here, that's okay. So I'll set this to be shaded. Hit OK. And we ended up going with a 1:1 scale on this one, so let's go back and fill that out. So our scale is 1:1 for that page. And our last page is going to be the link. And make sure you use all capital text, or all capital letters always here for your text. Never use lowercase letters. And we'll set up our final views here. And I'm going to use a 2:1 scale again, since that's what we used on the other page. Really, this is another drawing where you could get away with 2 views, but we've already got all 3 of them on there, so we'll just leave them for clarity. But really, I only need 2 views on this, either this view and this view, or this one and this one, but you don't need all 3 of them necessarily. So 2 views and the isometric would be okay on this one. So we used a 2:1 scale on this one. Hit OK. And let's go ahead and save here. Okay, so I'm going to go back to sheet 2. So sheet 1's finished, but I'm going to go ahead and center mark everything. So I'm going to go through all my sheets and put all my center marks on. So I like to do this stuff kind of in batches if I can. Okay, so we'll go to sheet 3, do our center marks there. Page 4. Page 5. And the reason I do this also is it keeps me from forgetting things. And page 6. So you want to pay attention to detail, and the best way to do that is to be methodical. Okay, now I'm going to go back to sheet 2 and do all my center lines. So anywhere I have a hole, I'm just going to use the center line tool to put those center lines in. And make sure you get both views. Okay, that one's done, so we'll go to sheet 3, do the same thing. Sheet 4, sheet 5. Make sure you check all the views always and get all the holes in every view. And finally sheet 6. Okay, so that's everything except for our dimensions. So remember, don't dimension anything on your assembly page. That's just for clarity. On your part pages, you can dimension anything in these views. Don't ever put dimensions on an isometric though. And then for these pages, same thing. So dimension your isometrics. Don't duplicate dimensions though. So if you've shown it once, that's good enough for the whole drawing. And you can work your way through these pages. So I'm going to pause for a second here and just go ahead and dimension my drawings, and then I'll come back and show you when they're all finished. But I'm not going to record the boring process of putting all these dimensions on. So I'm going to go ahead and save, pause the video, and do my dimensions, and I'll come back and show you what it looks like completely finished. Okay, so I'm back with dimension drawings, so I want to show you the finished product for this. So here's our complete packet of working drawings for this assembly, which all told probably took me maybe 50 minutes or an hour. So not too bad for an entire packet of assembly drawings. So if I look at my first page, and you can see here the dimensions that I needed for this one. So not too terribly complicated. This part you should be able to dimension with 4 numbers. So I've got some multipliers on here, notice. So if you want to put these on, all I did was to kind of show you, if I delete one of these, instead of dimensioning both arcs, I dimensioned one of them, and then just double click it, and you can type in the front, if you hit the home button, 2x, and just put a space and hit OK. Now that tells somebody looking at this drawing, both of these arcs, this one and this one, are a radius of 5. So you can use the multiplier to eliminate dimensions. If I look at my fourth page, very easy part to dimension, so 3 numbers on that one. This is the trickiest one to dimension, and they actually dimensioned it wrong in the handout. So if you look at the handout, they did some very poor things here, like this. They dimensioned the locations of these 2 circles in a view where they're hidden. So remember, you always want to dimension to visible lines if you can, instead of hidden lines. So you'll notice on my drawing, this dimension and this dimension I put up here in my top view where those 2 circles are visible. Something else they did on a lot of these drawings that's really bad is they dimensioned repetitive features. So they dimensioned both of these holes at a diameter of 10. Same thing up here. They dimensioned everything. So whoever made this has not been doing drawings for a very long time. That's a pretty commonly known thing, that instead of doing this, you use the multiplier. So you'll see on my drawing instead, I use 2 times a diameter of 10. That cleans up my drawing and eliminates a dimension. And I also didn't dimension to hidden lines down here. I took those dimensions and put them up here. So follow on this part, follow my dimensioning method, not the one that's in your handout, because the one that's in the handout is kind of the way a beginner would do it, and it's not completely correct. So here you can see the dimensions for this part. Dimension to visible lines, not hidden lines, and avoid repetitive dimensions. Okay, so There you can see the sizes for these. Some people would argue whether or not you need the dimension from here to here. I left it off, assuming that people will understand that this part is symmetric. So, really this is 20, but if you know that the part is symmetric, you'd say 80 minus 40 divided by 2 would give you 20 and 20. So I'm assuming that when someone looks at this part, they understand that it's a square and that the part is symmetric. If you wanted, though, you could add this dimension in just to be safe from here to here. It may not be a bad idea. But there's the general layout for this part, which is probably the trickiest one to dimension. And then the last one would look like this. So I'm going to go ahead and pull these over a little bit farther. Okay, and another trick that I wanted to show you that's useful when you dimension stuff is for things like this. When I put this dimension on, I kept having the trouble of it overlapping on top of this one. So if you get where this is happening, it's doing something like that, or you're trying to dimension from here to here, and it keeps putting the number on this side. When you dimension, whichever line you click first is the one where it's going to put the text. So on small dimensions, if I click here first and then the center, it's going to put the text on the right-hand side because that's the line that I picked first. If I do it in the other order and pick this first and then the other side, notice it puts the text on the left-hand side because that's the one I picked first. So you can adjust it after the fact, but it's a lot easier if you know why it's doing that, and you can avoid having to adjust it. Okay, so there are all the finished drawings for this part, or for this assembly. So hopefully, this kind of helps walk you through the process of creating your first full, complete packet of working drawings with all the necessary views and dimensions and title block. So now this is something that we could take and print out and give to somebody, and they could actually make this if we wanted them to. Okay, so I'm going to go ahead and save this. When you upload this to Blackboard, all I really need to grade this is your drawing file, but just to be safe, go ahead and take this and just pack it all up together in a zipped folder. So for instance, here's my folder with all my files in there, and I need to put my drawing file in there too, actually, so let's dump that in there. So here's my folder with all my parts in there. I've got all my pieces that I made, my assembly file, my presentation file, and my drawing file. So I would recommend you take all these, send to a compressed folder, and just upload this to Blackboard. That way I have all your pieces in case something goes wrong. I can see what you did. So for this, just zip up everything together in one folder, all the files all in one place, and just upload that to Blackboard. So that's it for this project on putting together the link assembly. So give it a try on your own now. Best of luck. If you have any problems, you can email me, jhamilton83@ivtech.edu, or you can come see me during my office hours in room T316 of the Technology Building. So good luck, and I'll see you either in class or in the next video.